Hello guys and welcome to today's video. This is going to be completely different from the trading bot because I'm going to be doing LeetCode. Now I've not done LeetCode properly before, I've merely looked around it and done a couple examples. However, I have an algorithms and data structures class coming, and for all job interviews it's a good idea to be confident with LeetCode style questions. So we will be following neetcode.io, I'll leave that website in the description, and we're going to be starting here at arrays and hashing and slowly going down and basically trying to get all this basic stuff done, and then we can maybe go on to separate and our own questions. The first question we should be attempting in arrays and hashing is, contains a duplicate. With any LeetCode, we have the question here, we have our solution here, and we get to run and submit it up here to see if we're correct. I'm going to be doing this in Python, and before we get into any coding, we're going to visualize and design what to do. So let's read the problem first. So we're going to be given an integer array of nums. Okay, so what we're going to write down here is our input. Our input is an array of type integer, which we see here. We will be returning true. Okay, so it looks like we're returning a boolean. We return true if any value appears at least twice in the array, and return false if every element is distinct. So if there's a repeated number, so we'll say in the data, with our data, if we have a repeated number, we're going to return true. And if there's no repeated numbers, we're going to return false. So we're going to use their example here. Our input is 1, 2, 3, and 1. And obviously with our human eyes, we can see here, visually, the number 1 is appearing twice, at position 0 and position 3. So in this case, we should return true because we have a repeated number. And if we have an input like 1, 2, 3, and 4, we should return false because each number is distinct. Now, before we get coding, what is something we could use, or like a data type or something we could use to figure out if there is non-uniqueness? So what is something that is unique? A set. A set is an unordered list kind of where everything is unique. So a set can't have 1, 1, 2, 3, 4, 4, 5, 5. It would just be, if you tried to add that, it would just be 1, 2, 3, 4. So one thing I see that we could do, I'll make up an input for an example. So this input 1, 2, 3, 4, 4, 5, and 6. If we loop through the given list and we add them to the set, our set would become 1, 2, 3, 4, 5, 6. And you can see here that these are different because this one contains duplicates and the set does not. So if we simply compare lengths, and you can see here that they're different, you would simply, so if the lengths are equal, you know that it must be distinct. And we know it from up here, if it's distinct, you return false. And if the lengths don't equal each other, then we return true. So let's attempt to implement that. So the first thing we're going to do is create a temporary set. And I think that's how you do it in Python. And we'll now write a for loop to loop through each number. So for a num in num, so num is the list we're going to be getting. We're going to add it to the set. And now, like we discussed, we're going to compare the lengths. So I've created two variables here, the length of the set and the length of the list, just make it easier to read. And just like we said, if they equal each other, we want to return false, else we'll want to return true. Now, I don't know if this is going to work, so let's figure it out. Yes, syntax error, it's a double equals, not equals. And we've got 3 test cases working. Let's run a submit to see if this works. And we're accepted. Perfect. So it works as expected. That was first try, that's pretty good. I think this is a very, very simple problem though. So because we managed to do that, let's see, can we tick this off? Oh, look at that. Perfect. Let's try out this next one, valid anagram. Okay, so valid anagram, we're going to write out the same as before. So our input is 2 strings, S and T, and they're both type string. Our output is going to be true if T is an anagram of S. Okay, so we're given our 2 strings here, S and T, which are both strings. We want to output, if T is an anagram of S, we want to return true, else we want to return false. So let's look at these examples here. So our input, we're going to use example 2 here. We've got, so for example 1, S is anagram and T is nagaram. And if T is an anagram of S, and an anagram is if it's the same word reversed. So if you look here, so I was under the assumption anagram was just a reverse, but it's not a reverse. It's as long as it contains all the same letters. Okay, so an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Oh, okay. So my immediate thought is a hash map. That's my immediate thought. I'll write that down. If we store a hash map, and we can see here our constraints is everything is lowercase English. If we hash map basically A to Z, lowercase English, and then we store the amount of occurrences each one has. So if the word was rat, we would store in our hash map R1, A1, and T1. And then we would compare that with car. We can see here that we have R, A, and T all have 1, but C, A, and R all have 1. These don't match, so something's wrong. So I'm just trying to think, how would I compare the hash maps? Well, if we assume each hash map, our hash map's ordered. Each hash map will have the same key, A through Z lowercase. So we would go through the entire hash map and compare the key value for A to A, and if it's the same, keep going, and then if it's different, break. It doesn't work. So that's so we're going to loop from A to Z, comparing the values, and if they're equal, return true, else return false. So let's get into trying to code this. Okay, so I'm doing it in my local environment just to make this better. And this is basically the function we're going to be doing. Lovely Python doesn't care if we have bool there or not. So I'm going to create a hash map now, 2 hash maps. I forget Python does not have a hash map, they use dictionaries, so I'm going to implement that. Perfect, here we've got our 2 dictionaries here, and they all have 0. Okay, here we go. I've got 2 simple loops going here, which loop through each of our strings. And if it finds the key in the dictionary, it adds 1 to the number. So you can see here, this is the first word, and the first word we were entering was rat. So we see here A is used once, R is used once, and T is used once. Okay, so what I've simply done here is we can get rid of these boring prints. For rat and car, we get false, which aligns perfectly with this. So we're going to try anagram, and we get true. So the way this works is it creates 2 dictionaries, both from A to Z. It loops through each string, and it will add to the dictionary the value. It will plus it by 1 for each character, and for both, like I showed you earlier. And then now for the final, we're going to go through each letter, so from A to Z. And we're going to compare the both A's in the dictionaries together, and then the both B's in the dictionary together, and the both C's, and then we're just going to go right down to Z. If those values do not equal, we return false immediately. However, if we manage to get through A to Z and they're all the exact same, we know the words are anagrams, and we return true. Only one way to find out if it works though, and we can see here, okay, for case 1 and 2 it works. Let's submit the solution. Amazing, we managed to do it. Look at that. And we didn't do too bad. Amazing. So that is the solution, which is great. So let's get back to here and let's tick off valid anagram. Perfect, we've done these 2. Now we're going to do one more. The next problem we're going to be attempting is to-sum. So let's read through this question first of all. Given an array of integers nums and an integer target, return indices, so multiple indices, of the 2 numbers such that they add up to the target. You may assume that each input would have exactly 1 solution, and you may not use the same element twice. You can return the answer in any order. So let's write this down. We're going to get a nums array, and it's going to be of type integer. We're going to get a target, which is of type integer as well. And we're going to output the 2 locations in the original list of the numbers that add up to the target. So my first thought is, there's obviously some sort of data structure here that works, but my first head would be to start with this number and check all of the other ones against it. If any of them added together is equal to the target, return that. And if not, go to the next one and check that, next one, that. You actually wouldn't need to check by new because you've already done that. So I'll show you here as an example. We'll use the first example. So we have our input nums, which gives us 2, 7, 11, and 15, and we're trying to target 9. So the way the algorithm works is we'll start on the first indice, which is going to be here, 2. We're going to compare 2 and 7. 2 plus 7 equals, oh, look at that, it equals 9 immediately. So that would be a stop right there. But let's just say that the target is something else. We know the target is possible, so if this number doesn't exist, then it's fine. Well, I'll just put it as, we'll say 26. We're going to compare 2 and 7. 2 plus 7 equals 9. That's not 26. So we're going to compare 2 and 11. 2 plus 11 equals 13. That is not 26. 2 plus 15 equals 17, not 26. So we've done all that. Now we're going to start on 7s. We don't need to go back on ourselves because if you notice here, 7 plus 2 is 9. We already done that right here at the top. We can just do 7 plus 11 equals 18. 7 plus 15 equals 22. And we'll keep going and going and going, and eventually it should hit. So that is going to be our strategy. So let's attempt to get that implemented. We're checking here that we're going to get the correct data in, and you can see here, yep, this is the sample data I'm going to use. So we'll do exactly what I said. Got a simple for loop going here. I originally was going to use for num in num, or number in nums, but because we're needing to return actual indexes, we should just keep an eye on where we're at. So here we go, 2, 7, 11, 15, that's perfect. For each number, we're going to loop through the rest of the thing, so it's going to be a loop inside another loop. And as you see here, this loop inside a loop is doing comparisons between each and every single number. Now, we have a restriction that it did say at the start. You may not use the same element twice. So we need to make sure that it doesn't compare 2 and 2. Okay, I've had to do a quick change. This is a bounds check to make sure we don't go out of bounds. We're not doing j plus 1, it's j plus I plus 1. So you can see here we compare 2 and 7, 2 and 11, 2 and 15, perfect. And then we don't need to check, but when we're on 7, we don't need to check 2, and we don't need to check 7, we just need to check 11 and 15. So 7 checks 11 and 15. And then here, 11 only has one check to do. Is 11 and 15. So all we need to do now is write a comparison. And if it equals target, we would just return the two indices. So if nums I plus nums I, or j plus I plus 1 is equal to target, you simply return I and j in a tuple. So I think we have the correct answer. I just realized it's not wanting a tuple, it's wanting a list as a return, so that should return our list of 0 and 1. Yep, perfect. Now we have other cases to consider. Okay, actually, so there's no cases in this example. As it says here, we assume that there will be one solution. So, shall we get this in and see what happens? I have no idea if this is going to work, but there's no harm in trying. Case 1, 2, and 3 all are successful. I'm going to comment out. Let's submit and see if we get a valid solution. The tension. Accepted. And oh my goodness, our time was atrocious. It's probably because we're doing a loop inside a loop. And when I think about it, I didn't actually use any any data structure here. So I assume that this is probably a hash, a dictionary that I've mistaken and didn't use. So let me double check. So it looks like we should have used a hash map because our solution's O(n) squared because we're doing a loop inside a loop. And if we used a hash map, it would only be O to the n. I want to take another look at the problem we did here. I was looking in the LeetCode solutions, and these are quite nice actually, I've just found out. This was showing the approaches here, and it's showing the first approach is a brute force, which is what we had, and we were getting, I think it was a 6-second time for everything. But the more effective thing is to use an unordered map, which I assume is like a set. No, it's not a set, it's a dictionary. Okay, so my understanding is we are going to create a dictionary or a hash map, but a dictionary in Python. And the key would be the index of 0, 1, 2, 3, 4, 5 to n. And the value will be the actual integer that was in that spot. Let's just do that first of all. We have our dictionary being created. Index 0 is 2, index 1 is 7, index 2 is 11, index 3 is 15. No, it's the other way around. We're wanting it to be the number, and then its value is its index. So 2 is the key to 0, 7 is the key to 1, 11. So, okay, yeah, so 11 is in position 2, 15 is in position 3, and that allows us to search the hash map or dictionary by the key, which will be, okay, so we're going to construct the dictionary, and with our dictionary constructed, we're going to say for number in the dictionary. So this appears to be working now. We're going to first create the dictionary here, which looks like this. We're then going to loop through each number and find the complement number, which is the target minus the current number you're looking at. So our target here is 6, so we're going to do 6 minus 3, which gets you 3. If 3 exists somewhere else in here, you know 3 plus 3 is 6. However, there is no other 3. So we're now on to this 2 number. We do 6 minus 2 is 4. So we know, wait a minute, if there's a 4 anywhere else in here, 4 plus 2 should equal 6. So we're going to check here, and we're not going to check the same number here, because you could have a situation where it's 3, so 6, you could have 3 and 3. So you can't check the same one. So we go 6, we're checking 2, difference is 4. Is there a 4 in this spot? No. Is there a 4 in this spot? Yes, there is. So we're going to return 1 and 2, which is exactly what we did. 2 and 1, same thing. And I think that gets us down to O of n, because you can see here, there's only ever one loop. There's not 2 loops. So we'll try this one out, which of course was heavily inspired by this guy, which did a very nice explanation. Perfect. Look at that. And instead of submitting it in 6,000 milliseconds or 6 seconds, we're now at 5 milliseconds, which is perfect. I think for next time, I'll make sure to, because obviously we're doing algorithms and data structures, you probably don't want to brute force it. So, and even if I do brute force it, I'm going to try and think of a way to just optimize it, which is great. So we can do both things and compare, which is cool. So I think that is good. There's nothing to tick off on LeetCode because we already did it, but at least we have a 5-second runtime now. So thank you guys for watching, and I will see you guys in the next LeetCode episode. See ya.